Welcome to day 6. Today we'll be covering actually lots of topics because we dedicated our yesterday's session to reviewing how the reduce works and doing some kind of solving some kind of tasks, etc. So we didn't go through kind of new topics. So today we will learn not only what you see on the screen, which is basically some type conversions, the difference between the referential and primitive values, referential types and primitive values. We'll see why an empty object or an empty array is not equal to another empty object or an empty array. But we'll also talk about some of the day 5 topics, right? So I'm going to start with day 5. Do a quick intro to what I was going to talk about yesterday, and then we'll move along with some referential types, primitive values, comparing this together, and also discussing the difference between the double equal operator and the triple equal operator, and why you should always use the triple one. So let us start with some objects again. So we have a couple of things we didn't discuss. Okay, so let me create an object and which has the key hello, and the value of that key is world. So the way I would access the key hello is, how do I access the key hello? On object. What was that? How do I?
Object. Hello.
So what was the other?
Brackets, karakusi.
What kind of brackets?
Karakusi.
Hello. Okay, so both of these will log the same thing. But what happens if my object is null? Or what happens if my object is undefined? You'll see that I get an error. And the error is we cannot read the properties of undefined, and also a very similar error we'll get for the null, cannot read properties of null. So whenever your value, of course, we can use TypeScript to kind of identify these cases where the value can possibly have value of null or undefined. However, in JavaScript, if you are trying to read a property, for example, of an empty object, that would be an undefined. So does not have, yeah, of course, now this is TypeScript giving me some kind of error. But if I would go into a browser, I guess, yes. If I would go into the browser, you can see that both of these console logs are undefined. So let me just maybe also put something there so you can see the logs. So both of the console logs are undefined. However, if I would say undefined.hello, I'll still get the error, and null.hello would still be an error. Now, there is a way to, in these cases, when your values are nulls and undefined, and you don't want to get the error, there is a syntax in JavaScript called optional chaining, and it does not only, and it works not only with objects. However, I'm showing that syntax, how to use that syntax with objects. So what you could say, you could just add a question mark before the dot, and as you can see, we get an undefined. We don't get an error. Okay, so imagine we have this variable const name. It either contain a string, which represents someone's or some entity's name, or it can have the value undefined. So let's imagine we have done some calculations, and as a result of the calculations, the name was assigned a value of undefined. Now, if we say name dot, now of course this should have been an object. So we're trying to get some kind of property on the name. So let's get name dot maybe last name or something like that, whatever. I'm just showing an example. We will get that error because now the variable name contains the value of undefined, and we cannot access kind of any properties on undefined because undefined doesn't have any object, it doesn't have any properties, any keys. And so to avoid the error in this case, now we use the optional chaining. Okay, so the question mark and dot, they go together. That's the syntax. So this doesn't work. This doesn't work. Well, this might work because the engine is kind of still able to bring everything together. So it's white space not sensitive, I guess, but you cannot just change the places of this. So I think this is, yeah, this is a syntax error. So this is an unrecognized syntax. However, this is a correct syntax. So we will get undefined. So this is a very powerful tool. Just know about it and use it, and use it as you go. Okay, so that's about the optional chaining and also accessing the keys of undefined and null values.
So instead of level, in this case, we receive undefined.
Yes, correct. Now let's imagine we have an object of the following shape. Okay, so student one, last on, and student two, student three, Leila, and student four, Rashid. Now we know how to kind of loop through our keys of the object, right? So we can do the for let key in object, right? We can do this, and when we do the console log key, we'll see all our keys. Now the way we get the values is console.log object key, right? So we access our object with the given key, and that will be, so if the given key is student one, then okay, then the value of that key will be right. So now we console log the key and then the value. Key, the value. However, there are other ways to do all this looping. So for example, what if we would like to get all the keys of the object, right? So now our task is to somehow get all the keys. So the solution to that at the moment would be to have an array of keys, right? Something like this. And then we would do the push, right? Dot push key. And when we do the console log, dot log, clear, dot log array of key. So now we have an array of key. However, in JavaScript, we have some nice and convenient methods on the object on this object. So we can say object.keys and give our object to this function, and it will return an array of keys. Okay, const keys equals to object. Now when we do the console log keys, we still get the keys. Okay, so let's put the one there, and or let's do this way, object keys. So object.keys is a function that receives an object and returns you the keys of that object. Now, what if we want to get the values, not the keys? There is a similar function for that too. So we can say values. What do you think the name of this function is? Values. Object dot values and values. Okay, fair enough. So it also gives us the values, right? So we can iterate through this array, or we can maybe send this array over the network to our backend, or do anything we would like with the values. And now we don't have to go through. Now we don't have to code a for loop to create an array manually, then do the push, or even do object key to get the values, and then somehow do something on this array. So we can just use object.keys, object.values. Now there is a way to create the object from an array. So there is a function called object.fromEntries. It receives an array of arrays. Now, these inner arrays, these nested arrays, represent the keys and the values. So in this case, const object one is from entry. So the name of the, let's name this first key as key 1 and the value as value 1, right? So I'll copy this couple of times, 2 and 3, 23, yeah, whatever. We're just looking for something, not specific values. And when I do console log of object 1, I'll get my object constructed from the array. So there is a way to construct an object from arrays of arrays, nested arrays. So you give this object.fromEntries a big array, then you have small arrays, and the first element of the nested array is the key of the future object, and the second element of the nested array is the value of that key. So as you can see, key 1, value 1, key 2, value 3, as we have here. Now, if there is a way to construct the object from this type of array, then there is a way to get such an array from the object. So let's see what that does. Entry array. Now there is another function called object.entries, and you give your object to object.entries, and it will return this array to you, so that you can do some mapping, do some maybe sorting or rearranging or filtering on the values, and then construct your array, your object back. So I'll do console.log entry array. As you can see, we'll get this big array and have all these nested arrays. So the very first element in this big array is an array, and the first element of that nested array is key 1, as you can see here, key 1. And the second element of our nested array is value 1, because the value of key 1 is value 1. Okay. So that's about that. Now, I'm going to also talk about JSONs, but just an FYI, okay? So I'll leave this to you to kind of research and learn, because there is not too many things to do with JSONs. There is just a couple of things to know, like methods, whatever it is. We will still use our object here, this object of students. Let me just grab it and pull it down so we have it in our vision. Okay. Now, what is a JSON? JSON stands for JavaScript Object Notation, and it basically is a format, is a way to format your data, whether it's in JavaScript. Well, it started with JavaScript because the name itself says JavaScript Object Notation, so it was kind of invented to be used in JavaScript. However, it became so popular, and it became such an efficient way to transfer data between like clients and backends, or even between the backends, or let's put services to transfer data in the internet. However, there are other ways to transfer data in a more efficient way, but it was so convenient to transfer the data, get the data somehow, parse it easily. Okay, it is not that complicated to work with JSONs as with, for example, XMLs.
Yeah.
Because with the XMLs you will have to have your structure defined, and you will have to have some tools, some old programming languages, for example, they like initially worked with XML because there was no JSON at the time, but once JSON was invented, a lot of programming languages and environments integrated all these tools and started supporting also JSON. So what we can do with our object here, we can console.log JSON.stringify of that object. Now, what that means. Now, let me assign the value of that to JSON string, and log it. And also, I will also console log the type of that variable. Now, as you can see, it is a string, right? So the result of JSON.stringify receives an object or an array. For example, we can do something like this, 1, right? There are different data structures in JavaScript which can be converted into JSON. Some of them cannot be converted into JSON. For example, functions in JavaScript cannot be converted, cannot be stringified as a JSON, cannot be converted into a JSON string. But arrays can, and objects for sure can be converted into strings. Now, as you can see, the result of JSON stringify is a string, as we can see in this console log. So it's a string. Now, the way the data transfer with JSON works, you just cannot, grab this object and send it to your backend. It doesn't work that way, because the communication between the front end and the backend is coded somehow, and it usually, if it's not just like binary or proto buffs or something like that, if it's not a binary kind of encoding, so if you just don't send ones and zeros, well, ones and zeros are the things that are sent in the end via electrical impulses or optical impulses. You just cannot say, just send this object to my backend. So usually it doesn't work that way. Usually the communication between the front end and the backend is sending and receiving some strings. Usually it works that way. That's a very simple kind of implementation of how to send these objects, arrays to our backend. So it also in JavaScript, it works that way. So when you do some kind of HTTP request, that's basically what you are doing. You're just sending some bunch of, if we are, of course, talking about these objects, okay? So when you're uploading a file to your server, it's not simple string, it's something else. It's a binary data. So I'm just talking about this specific case of this object. So to send this object, to send the data that we have in these objects, right, the keys and the values to the backend, we first have to kind of encode it in a way that we can then send to the backend. And that is usually the string, the JSON string, that if the communication between the front end and the backend is JSON. So the way to do that is JSON.stringify. Now, when we have the JSON string, then we can also construct or come back to this object. There is another method for that. Const JSON object. And there is another method called parse, and we give it the JSON string. And let's do console logs here, and let's see what it returns. Now, as you can see, this is our first log here on line 44. We stringified our object. It is a string as confirmed by line 45. Then what we do, we kind of construct back our actual object from the JSON string using JSON.parse. So there are only two methods to work with the JSON: JSON stringify, JSON parse. There is nothing pretty much else by default. So we construct back our object and we log our object in line 49. As you can see, it is an object. It looks like an object. It looks like a console log of an object. And then on line 50, we confirm that the type of the value that is inside that JSON object, it is an actual JavaScript object. So JSON parse is used to get the actual JavaScript object, and JSON stringify is used to convert the actual JavaScript arrays, objects, whatever it is supported by JSON stringify, into JSON strings, and these JSON strings can then be sent to server, to whatever it is, or stored in a file, etc. Right? So if you are trying to, imagine you are trying to write this object into a file. So the contents of that file is a text, right? It is not a JavaScript object itself. It is textual data. Whatever you put in your files, even the source code that we see right now, it is a text that we put in index.ts. So this is not something kind of, so this, in terms of the file, this is not an object. This is simply a text. So if you would just like to put your objects, arrays, whatever it is, into a file, you would have to first convert them into string to kind of do the JSON stringify and then write this into your files. Otherwise, it just doesn't work. There's no other logical kind of way to do it.
Եթե response-ը ստանում ենք JSON-ով, ավելի detailed որ բացատրեմ, էլի։ Response-ը JSON-ով ստանում ենք, որպես ինչ-որ գործողություն անենք, վերածում ենք իրան string-ի, գործողությունները անում ենք, հետո վերածում ենք JSON-ի, նոր հաջորդ response request body-ի մեջ դնում ենք այդ JSON-ը։ Գործողությունները տենց է լինելու։ Իսկ պետք է իրան string-ի վերածենք, աշխատենք, ասենք ինչ-որ property-ների value-ներ փոխենք եւ այլն, հետո էլի սարքենք իրան JSON, որպեսզի կարողանանք էլի ուղարկենք request body որպես։
So when we make some HTTP requests to our backend, the backend will send our JSON data as a string. So there is an API, there's a web API. It's I think it's supported in browsers, and I think it's also supported in latest versions of Node.js. So the way it works, you write fetch, which means make an HTTP request, and then you say, for example, make an HTTP request to https example.com. Okay, so make a GET request to example.com, which means get some data from example.com. Now, the way this fetch works, it gives you the response. Don't bother about the dot, then the syntax. Just don't bother. I'm just trying to make a point here. So what you get then is a response. And what you can do on this response, you can say, convert the response from the server into JSON, or convert the response from the backend into text, or convert that into a blob, and blob is like ones and zeros. It's a binary data, so it's not a text. So what you can do, what you usually do is, if the data that is coming from the backend, if it contains a JSON string, something like this, you can say, convert the data that is coming from backend into JSON. If the data is not a JSON, you will get an error, because our code will not be able to parse that data. If you are sure that the data that's coming from the backend is a JSON string, like something we have here, you can say, convert the response that is coming from the backend into JSON. And in that case, if then we say, then data, now this will be a JavaScript object, which will contain your data. Now imagine the backend responds with the student's string.
Then we convert it to.
Well, yeah, then we say, convert my response into JSON, then you will get this. You will get a JavaScript object that you can work with. Now, when you are trying to send your data into the backend, you have this object, but you need to get the string. Now then you will do the JSON.stringify on this object, get the string, and then send it to the backend.
Okay.
That's how it will work usually. Okay. So that's about JSONs. Now, just as a FYI, just know that when you do JSON.parse and you give it some invalid kind of data, this JSON.parse can throw errors. So you usually need to catch your errors here, right? You usually put JSON.parse in a try-catch block, and try-catch block, we didn't talk about this, but try-catch block is the way in JavaScript to catch synchronous errors. That there are other ways to handle asynchronous stuff in JavaScript. We'll get to that in a couple of lessons, I hope. So just know that JSON parse can throw errors, and you should be careful when you just call it without the try catch, because in that case you will have an error in your code which you do not handle, and that might break things. So this is just an FYI. Know that you should be parsing your stuff in a try catch block.
No, JSON.
Okay. So that was about the last session's topic, or yesterday's topic. Now, what I would like to discuss is, did I just close the? Yeah. I shouldn't have done this. So Excalibur. Now, what I would like to discuss is the referential types. Okay. Are the referential types and primitive values. So the majority of data types in JavaScript are primitives, right? Okay, so numbers, for example, they are primitive type because number is a number. You can do pretty much anything else with that. We also have strings. String, that's also a primitive type. You cannot kind of combine the number and the string. The combination will still be a string. So it's just one thing by itself. Boolean itself is also a primitive type. It's either true, false. There's nothing much to Booleans. Symbols are also a primitive types. What it is, we don't care. Just know that there is that kind of type. If you are interested about symbols, you can read about them, but we are not concerned with symbols in these. Okay. In that case, there is a referential type. But before we get to answer to that question, let's kind of draw what are variable for primitive values. Okay. So can I draw here? Yes, I can. So I'm going to draw some part of the computer memory. Okay, so I'm just going to draw some cells. This is some parts of the memory, right? Now I'm going to say memory and RAM. Okay, so this is part of my memory, and of course I have some zeros and ones. This is my data. And this might still go on, okay? So we can do like this. It is just like a part of the memory. Now in JavaScript, when we create our variables, let me capture that as a block here. So let's say we're doing const hello, okay? And it should be code. Now, when we're saying const hello and putting some kind of number in there, so this number is a primitive type, right? So we just basically say that the value that the variable hello just holds the number 34. So when we access the value of hello, we kind of straightly go to, you know, that part of the memory in the ROM, and that part contains the value itself. Now, however, this is slightly different for the referential types, which are, we're not going into too much details here, okay? So I'm just trying to give you a picture that when you do const hello equals 34, the variable hello refers directly to that value in your memory. Let's put it this way. We're not going into much details. Now, one of the referential types is our object, of course. Another referential type is array, right? So we're just discussing these two, objects and arrays. Now, okay. So now with the objects. Okay. Now, okay, let's do something else because we'll be doing the comparisons now. Now, new number variable. Okay. So number variable, and we give it the same value. Now it refers to another part of the memory, right? But when we do number variable equals to hello, now the way it works for the primitive values, which in this case is numbers, the actual values are being compared. So the actual value of variable is 34. The actual value of the primitive type 34, which is in the variable hello, is also 34, and hence this gives true. Okay, so for the primitive types, it works this way. It just basically compares the values. That's why we call them primitive types, because in the end, the values are being compared. However, with the referential types, when we have an object or an array, const array 1 equals to an empty object, and we have another array, array 2. Now, in this case, we do not store the actual array in the variable, but we store a reference. So what we can say is that we can just let's just copy paste this part. I'll bring it here. Okay, I'll do this. Copy paste. I'll bring it here. I'll do const array 1 empty array. Now, again, our variable still refers to some part in the memory, but this reference, this is not the actual value. To differentiate, I'll say actual value 34, actual value 34. However, here we get the reference to, sorry, reference to that and reference to this. Now, to just show that the references are slightly different, array 2, also an empty array. Now, to show that these references are slightly different, I will just put 0 here, okay? To just kind of picture that the references are different. So now when we compare array 1. We're trying to compare array 1 to array 2. Let's do, okay, it's code already. Now, the way it works, now it does not bring the actual value of the array here, but it brings the reference. So let's use these 1 and 0s here to capture the reference. And the reference for the array 1 will be 1, for example, okay? So this is just an example to show something. So 1, 0, 1, 0, 1, this is the reference of the first array. Now the reference of the second array would be 1, 0, 0, 0, 1. Are they equal? No. That is why we will get false. So comparing stuff for the primitive values and comparing variables that hold referential types is very different, because primitive value, when we compare variables that hold primitive values, the values itself get compared. So if it's a string, the string hello will be compared to the string hello, that will be still true. Okay, if it's a Boolean, true will be compared with true, and that's still a true. However, for the referential types, we do not compare the values, we compare the references. Even if we put the exact same object or array, so now these arrays are different. Even if they kind of physically have the same value, they have different references. So in this case, in the case of referential types, it is the references that are compared. And if the reference is different, even if the end value is the same, we will get false. So the comparison will give us false. Now let's go. That is a good question. That's why we're editor, so that I can show that we can do that. Now let's start with the primitive case, okay? Because there is we can't talk too much about primitive because again, it's just too simple. Let's just show one example here and we'll move to the objects and arrays. Okay, number 1, it has the value 50. Number 2 still has the value 50. Number 1, is number 1 equal to number 2? Is it equal to number 2?
Yes.
Yes. Why? Primitive types. For the primitive types, we compare. Now again, you can imagine the references to the number 50 can be different in these variables. Okay, it can be different. However, since the value is a primitive value, the values will be compared, not the references. Okay, let's go for strings. String 1, Yerevan, and string 2, still Yerevan. Are they equal?
Yes.
Yes, primitive values. Booleans. Boolean 1, I'm just showing it once, so you know for sure that it works, and then we will not discuss this. True or false. False. Boolean 2. Is false equal to false?
Yes.
Yes, it does. So, primitive types, too easy. Let's comment this out. Now we're getting to the referential types. Let's start with arrays. Array 1 equals an empty array. Array 2 equals to an empty array. 1. Is this equal to? No, it is not. Because again, we have referential types in our variables. And in case of referential types, only the references are compared, not the values. Do not be confused with primitive types. Okay, so let's go for objects. Object 1, and object 2. Are they equal? No. Again, referential types. Even if I would say key 1, and I would say key 1, doesn't matter. even if the value of these things is absolutely the same, like visually it's the same key, same values, nothing else, no other differences, still, because objects are referential type, only the references get compared, and that's why we get this error. Now, okay, so let's come to the question, to Oksana's question. So how to do it so that the reference is the same? Okay, now I'm not going to comment out anything here. Let's go for creating another array, array 3. Now, instead of creating an empty array, I will assign the value which is in the variable array 2 to our array 3. Now this is true. Now this is true. Why is this true? Because, again, in the variables, we store the reference to the value. Now, the reference in array 2 never changed, right? So when we create another variable called array 3 and put the reference, which was in array 2, in that variable, the reference in array 2 never changed, even if we change the value of this array, right? So we could have pushed something in the middle but we never changed the value of the reference in that variable. So now we basically, what we said is the following. Okay, so it was array 1, array 2, so sorry, okay, so let's do this way. Now, let me get the block, okay? Const array 2, const array 3. Now, let's imagine that array 2 points to somewhere in the memory. Okay, so yeah, let's bring this somewhere here. I will zoom in, then I will connect both of these together. So this is my array 2, okay? I put an empty array in our array. Now, reference to our empty array. So this is a reference. Now, our variable array 2 contains the reference to our empty array. Now, when we say array 3 equals to array 2, now what we do, we create another variable called array 3, which basically refers to the same thing, but the reference is the same. So we can basically say, we can do it like this, okay? So the reference here is basically the same. So the kind of reference value in these variables is the same, or we can just do it like this. Because this is the value of our reference, same reference. So now when we say array 3 is equal to array 2, instead of creating a new part in the memory and directing this to here, and in this case, the references would be different, we actually point them to the very same thing in the memory. And that's why when we say is array 2 equal to array 3, that's why we get true. So this is referential type. Now let's see how this works with functions. We did not look up the functions yet, but let's just give an example. Function 1 equals to function, or let's just do it this way, okay? An empty function. Now function 2, and then we need to compare them. Function 1 and function 2. What do you think the result of this is? Just a guess. How many options? How many options are there? Okay, no. How many options are there?
True, false.
Why?
And
Why are there?
Because they are objects, seems.
No.
That's why it will be false, no?
No. The question is, we are trying to compare one function to another function, or we're trying to compare two things. Why are there only two options?
Because it's a compare, it would be yes or no.
Was it too easy?
Yes.
Was it too obvious? Yes, because we will get a Boolean as the result, and Booleans have. Were you trying to do some quantum mathematics in there, right? Again, the QA, right? So I'm poking your QA, your inner QA, and it works, and it works. Good.
Maybe also undefined, not only true or false.
How will you,
Error.
how will you get an undefined from a comparison?
Not sure, but it is possible.
Okay. I'm going to move on because we maybe find out that we can also get a string after the.
Yeah.
Nice, good job. So what we get is still false because again, functions also are references. So it's another referential type, but since we did not learn functions yet, that's why I didn't put them in the referential types, but now we can put it there, functions. Function, okay? So we have a few referential types, a few types, a variable of which hold references, not, no, let's not put it that way because the variables of primitive types also hold references, but when you do the comparison, that's where the difference kicks in. And not only then, when we get to functions, we will see also another kind of difference between referential types and primitive types. However, since we're talking about comparing stuff, the difference here is, imagine it this way. All variables hold references to somewhere in the memory. They don't kind of hold the value itself. But when you compare primitive types, the actual values are being compared. Now, when you compare the referential types, the references are compared. If the reference is the same, you get true. If the reference, even if your both variables point to empty objects, empty arrays, empty functions, same kind of function definition, if the reference of the referential type is not the same, if the referential value in your variable of that referential type is not the same, you get false when you compare this stuff together. So very important difference. You should know this by heart. Okay, it's not hard to remember, but you should know that if you compare two variables that hold numbers, the numbers itself get compared. You compare strings, booleans, symbols, whatever primitive type it is, the actual values will be compared. Objects, arrays, functions, and whatever kind of other type it could be, they will be compared by reference. If the reference is the same, like here, you will get true. Otherwise, always you will get false.
Or can I ask a question?
Sure.
So about objects and arrays, there are many cases that we have to, or we want to compare one object with another or one array with another, but I can't imagine a use case when we should compare a function with a function.
Sure. I was just making a case that functions are also referential types. Yeah, sure. Yeah, you normally, I never compare functions on my day-to-day job. However, I was making a point that functions are also referential types. Just so you know. But of course, I cannot think of a situation where you would compare functions. That's correct.
And if we want to compare arrays, we should convert them into something comparable. Is that the point? For example, to string or.
Very good point. That's actually a very astute observation. Good job. So imagine now we have these. Let's start with arrays, and then we will get to objects. Now our array 1 contains two numbers, 1 and 2. Array 2 contains the same set of numbers. Now, knowing that we just cannot say 1, 2 is equal to 1, 2, because this leads to false, what do you think we should do knowing about all these array methods, right, that we'll learn that are in the cheat sheet? what do you think, what kind of trick or what kind of function or what could we do to compare these
Compare
arrays?
its values.
Pardon?
Compare its values separately.
And how do you do that?
Stringify
Like,
your array and then compare.
Stringify,
some method.
how do you stringify an array?
Like type would be string. I can't imagine it is in Java, but in JavaScript, but I can imagine. I mean, parse int, parse.
You
How to parse
You can
into type.
split the array. The split is on the string. Okay, but you're close. There is
Join.
another method. Join, correct. So what we can say, what we can do is we can say 1, 2, join. How do I write this?
Empty string.
Okay. Is this equal to 1, 2, join? We can do something like this. Okay. So this could be one of the ways to just kind of stringify the values, to stringify the values in the same way and compare them. Now, when I say stringify, what else we can do?
The empty string plus array. Can we do so?
I don't know. I mean this?
Yeah.
Maybe it can do the job. I don't know. Let's see. This is not something.
If I'm
This is not something I do all day, but it's logical that it would be converted to a string, so it is. Yeah, another way to convert to the string. But when I said we can also stringify the array,
JSON.
yeah, so we can do JSON stringify 1, 2, and compare that to JSON stringify 1, 2. This can also work because if we do this, it will say true. So you can also do something like this. And of course, you could just when comparing arrays, for example, you could start with comparing their lengths, right? So if the length of the array is not the same, you just say they're not the same arrays, obviously, right? So if my first array would be 1, the second one would be 2, you could just simply compare the dot length first. If they're the same, then kind of move forward with doing some other comparison. Otherwise, just for all these cases where the length of the arrays is different, you just return false immediately. You could also do something like that. Okay. So now we've kind of seen why is this false or this is true because empty object is not equal to empty object. That is true. We can do the console log and then see that empty object not equal to empty object. Another, so this is going to be true since, could you just log the thing, please? Just TypeScript trying to be too smart. Inspect. Okay. Let's go to a slightly dumber environment to test our code. Console. Now, this is true. Empty object is not equal to empty object. And the same way, empty array is not equal to empty array because the references to this empty arrays is different. It is not the same. That is why we get that. Okay, so that's about the referential types and primitive types. We will talk more about referential types when we get to functions. Okay, so I don't have anything here, so let's see what we have here. Type conversions during the quality check, primitive value equality checks, we've seen that. Reference value equality check, we've seen that. Now, regarding the equality operators, right? So in JavaScript, we have two, the double equality operator What's this in JavaScript?
Assignment.
Assignment operator. This is the assignment operator. This is the double equality operator, and this is the triple equality operator. Now, the way double equality operator works, it kind of tries to be smart. If you say, is one equal to the string which has one in it and nothing else, the double equality operator will say, yes, they are the same. So it kind of tries to convert types into something common and compare them together. However, if you say, if is one triple equal to one, it will say no, because it will also look into the types. It looks into the types are different, so immediately it says, no, they're not the same. What the double equal sign does, it just kind of tries to coerce or kind of convert values into something common and compare them together. We're not going to talk about the coercion rules. I don't know all the rules by heart. I never learned them by heart. I just use the triple equality sign because it's much safer. This is not recommended to be used at all, the double equality sign. The only one case I would consider using it when you have a variable, it has the value undefined, and you are trying to see if the value of that variable is either undefined or not. So this is the only value, this is the only case I would use the double equality operator, because if I would do the triple equality operator, it would set false, because undefined is not strictly equal to null. However, if my intention is to simply check if the variable name contains either undefined or null and nothing else, I would, in this case, maybe I would consider using this, because name double equals null is true, and name double equals undefined is also true. Anything else is false. This is the only use case I would consider using the double equality sign. So the rule of thumb, always use the triple equal operator, and you will be on the safe side of the things, okay? Because as we have seen, it does not do any kind of type conversions, right? I don't know if the double equality sign will do that. It will not. So, but as you've seen with the example of numbers, it kind of tries to be smart here, and then sometimes it just bites you in the known place, if you know what I mean. Okay, so that's about the equality operators, okay? Just always use the triple equality sign, the triple equality operator, and you will be good. And about the type conversions during the equality check, again, the double equality sign does do some type conversions. It's called type coercion, okay? So there's a table in JavaScript, you can look it up in internet, and it shows when you compare two different types of variables and you use the double equality sign, to which type each value will be converted to then be compared. It's a big table. I never memorized it. I just always use the triple equality sign and forget about that. But if you are curious, you can look it up. That's about comparing all the stuff together. And let's do 10 minutes of break, and then we will try to solve a task. Yeah, you can use Google to look up how object.entries work, how .filter works, and object.fromEntries work. You can use Google, you can use that. You have only 20 minutes to solve this, and after that, you will have it as a homework. And the deadline, as usual, will be tomorrow 10 a.m. If there are any questions before you start with the solution or thinking about the algorithm, you can start asking the questions and then get to the solution. Okay, so I'm going to pause the recording here, right? So we'll be just waiting for 20 minutes or so. So I'm going to pause the recording.